Alright guys, so here's the other half of 4.4 here, the other quadratic model that I wanted to look at. This one feels a little bit more tangible, it's a little bit more, you can kind of visualize it a little bit better, I think. This one's actually in section 4.4, it's on page 308, it's number 10. And so what it says is there's a farmer, and a farmer wants to build a fence. He has to fence in a rectangular area that's kind of up against a highway. And he has 2,000 meters of fence to do it with. And what he wants to do is he wants to make sure that the space he makes is the maximum area that he can get. He doesn't want to, because he can make this rectangle very skinny or very long this way, but he wants the rectangle to, whatever shape he makes it, to have the most area inside of here to kind of maximize his space so he can do whatever he's got to do. Now this plot of land happens to be up against a highway, so he's only going to fence these three sides. He's not going to fence this side because he doesn't need to fence it over here because the highway is there. He's good there. So he only wants to fence these three sides. So this right here is like the highway. Let's write that down. Highway. There's the highway. And then this is like the fence right here. So the question becomes, well, what dimensions did he actually make it to make the most area possible? So I don't know, but we can figure it out. Let's just say this. These two lengths here, this one here and this one here, they're the same because it's a rectangle. So let's just call that x. X here and x here. So he's used x meters of fence here and x meters of fence here. We don't know what that is, but you know, it's whatever it is going to be the same both here. Now here's the thing. If he's used x meters of fence here and x meters of fence here, how much fence does he have left over to put here? If we knew the number, if we knew this was like 10 meters, we would do 10 plus 10, that's 20, and then we'd subtract that from here, and that's how much we'd have. But we don't know what it is. So we started off with 2,000 meters of fence, and we removed x meters and x more meters. Those two lengths are not available to us anymore. So we had 2,000, and we got rid of two x's. 2x meters, whatever that is. Okay? So that's how we get our dimensions here. This is x, that's x, and what's left over is this 2,000 that we started with minus the two x's we just used. Okay? So now we have the makings for what we're going to do. So let's see. So let's see now. He wants to maximize the area in here. So how do we find the area of a rectangle? We should remember this. It's length times width. Right? That's totally a W. And so length times width, right now we've got x times it's 2,000 minus 2x. We don't know what these numbers are yet, but we just know that this is how we would find the area of this. Okay? So we can distribute here. So we can do like this. And I'm going to change the order around, so I put the squared piece first. Okay? So I'm going to do x times negative 2x, and it's negative 2x squared. And x times 2,000 is a plus 2,000x. So this is going to be, I'm going to call this the area function. So we're going to call it a of x, and that's our area function. The way this works is we could guess and check. We can kind of like say, okay, well, what if it's 10 meters? We'll plug that in, and then we'll see. We'll do 10 here, and then we'll put 10 in here, and 2,000 minus 2 times 10, figure out what that is. And then we can multiply this side times this side, and we get an area, and we can see what it is. Then we can say, all right, what if this is 30 meters? We plug in 30, do the whole thing again, and multiply, and there we go. What we've done here is we've already done the multiplication. So we've multiplied this already, and now we have this. So our function, what this gives us is if we put in the value of x, the value of this width, then the number that, once we do the math, the number that comes out will be the area of it already, because we've already done the multiplication piece of it. Okay? So this is the equation that will give us the area in terms of this side. So however long this side is, this will tell us how much area it is if we use that length of a side. Okay? So this is, again, this is a downward facing parabola. It's a negative, it's a square, so it's a parabola, and it's negative. So we're looking for, it looks something like this. Very, very generally, look at that. So we're looking for this point right here. Going across the bottom, this is like our width right here, and going across the top, that would be like our area. And so what we need is, we need this place right here. This magical value, whatever it is, will be our width that will maximize the area, because that'll be the x value of our vertex. Okay? So all we gotta do is go back here and let's find the x value of the vertex. So remember, the x value is negative b over 2a. So in this case, there's our A, there's our B, so it's going to be negative 2,000 over 2 times the negative 2, that's A. And that's going to be negative 2,000 over negative 4, looks like 500. So that's our length of our side that will maximize the area. We know now that if this length is 500 right here, that will give us the maximum area, because that is the x-coordinate of the vertex right here. Okay, so we know that this is how long it has to be. But so okay, that's good. But so now, how long, or what is that area going to be now? All right. Well, we could do it two ways. We can plug in 500 here. We can figure out this length and then multiply, or we can plug in the 500 into this equation. Let's plug 500 in here. All right. So we'll do A of 500. Plugging in 500 to this function. So we'll have negative 2 times 500 squared plus 2,000 times 500. Plugging in 500 for x. So over here, 500 squared is, I got it over here, it's 250,000 plus 2,000 times 500, I'm pretty sure that's 1,000,000. There we go. Good deal. Okay, so now negative 2 times 250,000, that's negative 500,000 plus this 1,000,000. And then we add these together, and it looks like we get 500,000. And what that tells us is that if, this is square meters, so if we have a length of 500 meters here, we will have the maximum area, and the maximum area that we get will be this 500,000 square meters. That's how that works, because that's what the coordinates of the vertex is. All right, and we can go through, if we want to find the dimensions of it, we can say that's 500, and we can plug 500 in here, and so it would be what? It would be 2,000 times 2 times 500. That's 1,000, so it would be 1,000. So it would be 500 by 1,000. So the way to make this thing, if this is 500 by 1,000, that will maximize the area, and we'll have an area of 500,000 square meters. All right. So there's one very much like this in the homework, and also one much like this in the review as well. Okay. So take a look at that. This one, it's the very similar concept as just it's all about kind of finding the vertex of the parabola, and as long as it's a downward facing parabola, we know that we're going to have a maximum value, and the x value is the in this case was the width, and then the y value was the area. So give that one a try, and let me know how it turns out.